Yeah, good afternoon, students. So this video is on a self-learning topic. Request the students to come to the class after watching this video. So it will help you to clearly understand the classroom discussion topic on accessing IO devices. So now I would like to share my screen. So the self-learning topic is on accessing IO devices. So how do we access these IO devices in computers? So this self-learning topic will develop the students' knowledge on how the data can be transferred between the processor and IO devices. So transferring of the data between the processor and IO devices. So this is how these IO devices are getting connected through a interconnection network with the processor. For example, if you take this is a processor and this is the memory, and these are the different IO devices. So IO device 1, IO device 2, IO device 3 and IO device N. So they are interconnected through a interconnection network. So these are nothing but we are calling it as the interface, an IO interface. This is called it as a memory interface. This IO interface is used to connect this IO device to the processor via a network. So like that we are making use of an interface respect to IO device interfaces as well as the memory interface, and we are connecting these IO devices and processor and with the memory. So the components of a computer system communicates with each other, the processor as well as the memory. They will be communicated with each other through an interconnection network as shown in this particular diagram, how they are communicating. So for accessing of this IO device, the interconnection network consisting of circuits which are needed to transfer information between the processor, the memory unit and the number of IO devices. So the interconnection network is consisting of circuits which are required to perform the data transfer between the processor and the memory unit, between the processor and the different IO devices. So the load and store instructions use addressing modes to generate effective addresses that identify the desired locations. So in the previous sessions, we already discussed about the syntax of load and store instruction, as well as what is the purpose of this load and what is the purpose of this store. So which is used for performing the read and write operations between the processor registers as well as the memory addresses. So the idea of using addresses to access various locations in the memory can be extended to deal with the IO devices as well. Just like how we are accessing the memory at locations, memory addresses from the memory unit, the processor will make use of the same idea of accessing the memory unit. The same mechanism can be used for accessing of the IO devices as well. So for this purpose, each IO device must appear to the processor as consisting of some addressable locations, just like the memory. If how the word we are storing in the memory, okay. So in the memory you are storing this. This is the address where the memory word A is available. Similar to that, we are making these IO devices which should appear like a memory addressable locations to the processor. Each IO device will be storing at different memory addresses. So that is the reason here what we are using here is that some addresses in the address space of the processor are assigned to these IO locations rather than to the main memory. So these locations are usually implemented as bit storage circuits organized in the form of registers. So some addresses in the address space of the processor are assigned to these IO locations rather than to the main memory. Fine. So it is customary to refer to them as IO registers. So since the IO devices and the memory share this same address space, this arrangement is called it as a memory mapped IO. So that means in the main memory itself, some memory locations, some memory addresses are designated for IO devices. For example, from memory address 1000 to 1050, these memory addresses or memory words are used for IO devices. Then this is so each IO device is stored or mapped to a particular memory address. So 1000 memory address into this IO device 1 is mapped, and 1004 memory address this IO device 2 is mapped. So like that we are mapping the n number of IO devices onto this designated IO memory addresses. So this arrangement is called it as a memory mapped IO. So with memory mapped IO, any machine instruction that can access memory can be used to transfer data to or from an IO device. For example, if data in is the address of the register in an input device, the instruction load R2 comma data in, the instruction load R2 comma data in reads the data from the data in register and loads them into the processor register R2. So from data in to the R2 register it will be loaded. Similarly, the instruction store R2 comma data out, which will sense the contents of R2 onto the register location called it as data out, which is a register associated with an output device. So this is what about the accessing IO devices by making use of memory mapped IO and by making use of data in and data out registers. Okay, so after completion of this self-learning topic, you should be able to perform data transfer between the processor and IO devices. Okay, so thank you for your listening to this video. Thank you one and all.